It requires a huge amount of research planning, a huge amount of collaboration, similar to what AI is now. It really depends on the overall capability. It takes years and years of planning, just diligence and persistence. There's no magic.
ตลของเรามีนักวิจัยที่มีศักยภาพสูงมาก
คณะวิศวกรรมศาสตร์มีนักวิจัยชั้นแนวหน้าของโลกและของประเทศในการ INNO Talk จะนำทุกสิ่งของคณะวิศวกรรมศาสตร์มาพูดคุยกับทุกคนเพื่อให้รู้ว่ากว่าจะเป็นนักวิจัยระดับโลกและระดับชาติต้องดำเนินการชีวิตอย่างไร
My name is Matthew Paul Gleeson, but I'm known as Paul. I was born in Ireland. I studied for my first degree in Manchester. I studied industrial chemistry. After that, I did my PhD again in Manchester in physical chemistry. After that, I went to work with AstraZeneca Pharmaceuticals as a postdoctoral researcher for 3 years. Then after that, I went to work for AstraZeneca Pharmaceuticals as a computational chemist. And then after that, I left industry to go into academia. So I met my wife, who's Thai, who works at the same university here at KMITL. We met during our PhD, and so after working in the pharmaceutical industry for maybe 7-8 years, I decided to move to Thailand. I first moved to Kasetsart University, the Department of Chemistry, worked there for 7 years, and then 7 years ago I moved to King Mongkut's Institute of Technology, La Gravang, to the Department of Biomedical Engineering. The impact I've had is partly because I work on applied chemistry projects that are sort of focused on optimizing or to improving drug discovery processes. So a lot of the work that I've done is computational analysis, data mining analysis to try to understand the properties that drugs need to have and how we can develop them better. Another aspect of my research is on designing and synthesizing molecules to inhibit certain biological targets. So we've got design and synthesis, and then with collaborations abroad and in Thailand also, we've got biochemical collaborators who can test the compounds that we've designed and synthesized for diseases like cancer, malaria, inflammation. So we've synthesized maybe a few hundred compounds in our group and published quite a few papers in this general area. When I was doing my first degree, I did a work placement in AstraZeneca Pharmaceuticals in the UK, and I was working in an analytical instrumentation department measuring properties. But I attended a seminar where I saw computational chemists building complex models of proteins and simulating how drugs bind to a protein and being able to calculate parameters, estimating, and I was fascinated by how you could use a computer simulation to design a molecule. So after that, I did a PhD basically looking at the simulation of these types of molecules and how they could interact. When I finished my degree, it was quite difficult to get a job in that field, so I ended up working in big data, machine learning of pharmacological parameters using quite sort of similar to what AI is now. In biomedical engineering in KMITL, we've got quite a multidisciplinary group of people, so it has been more easy to set up a laboratory. So we've got a synthesis laboratory where we can purify and characterize the molecules, and hopefully in the future going to be able to develop biological methods that we can test the compounds. But that's quite a complex task, so at present we really focus on getting external collaborators, experts in the field to test the compounds. But it's a very expensive, very time-consuming research work that requires very good quality master's degree and PhD students to work on these types of projects, and it takes years to publish a paper on, say, an anti-cancer project or an anti-malarial project. So it requires a huge amount of research planning, a huge amount of collaboration, and really committed and hardworking students to do the research. It's not simply turn up, do 6 months of routine work and publish. It takes years and years of planning. Locally in KMITL, so we would collaborate with College of Materials, Innovation and Technology. They have got a lot of advanced equipment that we would need to do research. We also collaborate with the Faculty of Science. good equipment center, so we can pretty much characterize molecules completely within the university with some testing having to be done outside. But we've also got, I'd say the key region where we've got collaboration is in the biological testing. So former colleagues of mine at Kasisart University, we've got collaborators in Naresuan University, Faculty of Pharmacy. We've also got collaborators in Mahidol Medical Technology that we've worked with. And in the UK, we do quite a lot of research with Dundee University on malaria compounds. International collaboration is really important too. So we've got collaboration with a number of different UK universities. So over the last few years, we've collaborated with the University of Sussex Drug Discovery Centre. We worked on some anti-malarial projects with them. We also have done anti-cancer research studies with the University of Leicester Cancer Research Centre. And again, these collaborations are critical because they've got huge amounts of expertise, huge amounts of equipment to characterize the biological molecules. I'm not exactly sure what characteristics lead to success, but there are certain, you can have multiple characteristics and be successful, but I would say what I've seen for the most successful people, generally it involved some level of intelligence and hard work together. So you could be extremely intelligent and not work very hard, still achieve success. And there are other people who are maybe not the most intelligent but work super hard and they can achieve high levels of success. So it really depends on the overall capability, which is a function of these two factors. For students in my group, I always try to tell them that you should always try to understand both your strengths and your weaknesses, and always try to maximize or work on your strengths. Acknowledge your weaknesses. You can try to improve them, or you can try to avoid working in an area where you know that your weaknesses are going to become a liability. There are different approaches. Different people can achieve a success under different circumstances, really. But yeah, I would attribute it down to hard work and understanding your strengths, trying to not maybe work in an area where your weaknesses are more noticeable, or that generally leads to more positive outcomes. I think it's just a slow, steady process. You come in every day, you work to the best of your ability, and over time you accumulate knowledge. The more you work, the smarter you work, the more you accumulate, and the more capable you become, the better able you are to solve problems in your field. There's no magic, I don't believe. I mean, you can be lucky and fall into a field that happens to be very successful at a point in time. That can't happen everyone. So I think it's just diligence and persistence and strength of character, and just a desire to want to achieve and make new breakthroughs.